In this session, let us see torque equation of induction motor. Okay, basically like speed control will be there, braking will be there. Like from analysis point of view, we may say like speed control, variable voltage, variable frequency control method, or rotor resistance method, or maybe some other methods. Okay, or kind of like in braking also plugging will be there, so many things will be there, but altogether to solve the problems of normal torque speed characteristics. Basically, why torque speed characteristics? Because torque speed characteristics are going to be external characteristics for any motor. Okay, for example, if I keep on tight the belt, okay, so for a given torque, at what speed it is going to be rotated is going to be torque speed characteristics or external characteristics. Okay, so beyond that, two more characteristics which are important, okay, in induction motor only. Because if you think of like in an induction motor from rotor point of view, for example, S equal to 1 here. Okay, so if S equal to 1 is here, this is going to be starting torque, starting current. Okay, so if this length is going to be starting current, so how much is the torque developed? Torque developed is going to be this much. Okay, so how much is the magnitude of starting current is high, and how much is the starting power factor angle is high, or power factor is going to be less, power factor angle is more, so cos of more is going to be less. So there are two disadvantages in primitive induction motor. Okay, so what are those disadvantages? Very simple. Means starting currents are high, starting power factors are less. So apart from torque speed characteristics, because like it is not like okay, in one book they have given, so we have to remember those. No. Okay, basically in no other motor we focus on this, but here in induction motor we focus on starting currents. Okay, our magnitude of current, how it is varying from S equal to 1 to S equal to 0 has to be analyzed, because starting currents are less, more, magnitude is more, and starting power factor is less, so there are three characteristics primarily we have to analyze, apart from efficiency characteristics. Efficiency in the sense it has its own significance, because losses efficiency or power calculations are done. Okay, so what are the things we are going to discuss in induction motor? 4. What are the characteristics? Torque speed characteristics are external characteristics. Our speed is nothing but slip, so torque slip characteristics. And second one is like current characteristics with respect to speed, magnitude of current, power factor characteristics with respect to speed, and then next is going to be efficiency calculations. Okay, now let us see. Where is my model? My model is Steinmetz model. Let me consider. Okay, so if I consider Steinmetz model, this is going to be R2 by S, this is going to be X2, this is R1, this is X1, this is X0, this is V1, this is I1, and this is I0, and this is I2. Actually I2 dash, but it's okay, I2 is fine. Okay, in induction motor, basically rotor analysis is nothing but analysis of induction motor. We need not have stator at all, because stator has been already analyzed in synchronous machine. So our focus is not here, our focus is only here. Okay, so let us convert this into Thevenin's equivalent. Okay, so if I convert this into Thevenin's equivalent, already we know how much is VTH is going to be this divided by R1 plus J X1 plus X0. Okay, X1 plus X0 into J X0, open circuit voltage. Don't focus on these particular equations, because in the exam, even if they give the values, you know how to use your calculator rather than remembering formulas. Forget about it. Now, for example, how much is ZTH? ZTH is going to be across this. After short circuiting ideal voltage source, we have to finalize like Z Thevenin is going to be this, and this will be in parallel. So R1 plus JX1 in parallel with JX0. Okay, so don't remember these formulas at all. Okay, so after that, like if I convert everything, this is going to be RTH, XTH, and this is going to be X2, this is going to be R2 by S, this is going to be R2 by S, this is going to be X2, this is going to be XTH, this is going to be RTH, this is going to be VTH, this is going to be I2. Okay, now just like see this. Okay, so if you can remember, actually nothing is there to remember, but anyway, if you can remember this, our, like, induction machine analysis, 70% or 75% of old gate questions, everything you can, what do you say, solve only by saying this. RTH, XTH, X2, R2 by S. In your exam, directly they may give RTH, XTH, and they may give this also, and they may ask you power or something, whatever it may be. Or they may consider these are neglected, only focus here, depending upon the question we do. So how much is I2, dear? I2 is going to be VTH divided by RTH plus R2 by S square plus XTH plus X2 square. Isn't that not? This resistance plus reactance, resistance square plus reactance square under root. Why I am writing equation for current? Because starting current magnitudes are high, so I have to keep a focus there. Okay, now after that, what is power factor? Why we are thinking of power factor? Because starting power factor of induction motor is very less. Now if you think of power factor, R by Z, no? So RTH plus R2 by S divided by same under root of RTH plus R2 by S square plus XTH plus X2 square is going to power factor. Okay, so these two are important things. Okay, actually we need not remember, don't remember, this is enough. Okay, now after that, how much is the air gap power? PG is nothing but rotor power input. Okay, so how much is rotor power input? I2 square R2 by S. Okay, so this is going to be I2 square into R2 by S. Rotor input power is nothing but air gap power. So for example, if I want to calculate torque developed is nothing but PD by omega R or PG by omega S. So PG by omega S I am going to consider. Why? Because omega S is going to be constant. So how much is PG by omega S? I2 square into R2 by S divided by omega S. If I think of, this is per phase. If I think of number of phases are M. So M. Okay, if it is 3 phase, 3 times. Okay, so means this is going to be M by omega S into I2 square R2 by S. Now this is going to be M by omega S into I2 square. Okay, so don't think of this, just think of this, I2 square. So VTH square divided by R2 by S plus RTH square plus XTH plus X2 square, I2 square. Okay, so I2 square, what is root got cancelled, into R2 by S. Okay, so if you can, like, we need not remember anything, just to focus on this. Okay, focus on this. Okay, then everything fall in place. Okay, so this is going to be torque developed. Now in this, like, as I am going to focus on the rotor side only, let us neglect stator side. Okay, so actually, is it negligible to neglect stator impedance and all, for example RTH, XTH? No, it is not negligible, but somehow we are here to derive the torque speed characteristics, some equations, because those equations has to be used in the examination, that's it. Okay, so RTH, XTH are not at all negligible, but as our focus is here, let us neglect them. If I neglect them, torque developed is going to be. Okay, so for example, if I neglect RTH, XTH, means that this is neglected, no? Okay, means that V1 will come here, no? Okay, so this is going to be M by omega S into V1 square divided by R2 by S square plus X2 square. Means that in this equation, keep V1 here, remove these two is going to be that, and into R2 by S. Okay, so in this, let us divide this into starting conditions and running conditions. Actually, we are not going to remember any equations there, please. Okay, so we are going to remember only this. While solving problems, automatically you will come to know the clarity about it. Okay, so starting running, at starting conditions, how much will be the stator rotor frequencies? For example, I strongly hold at the rotor not to rotate. Under that condition, stator frequency is F1, rotor frequency also will be F1. Okay, so if rotor frequency is F1, what about the rotor reactance will be more? Okay, so under that conditions, again, it is not negligible or something. Okay, but ultimately we are here to derive one equation to solve the problems. That's it. Okay, in detail course I will tell you, like, why, when, like, how and all we will see. Now in starting conditions means compared to R2 by S and X2. Okay, so if you think of X2 should be considered as starting. Okay, yet starting, how much is S? Roughly unity. Okay, so R2 by S is going to be less, X2 is going to be more, so neglect R2 by S. Consider only X2. For example, in running conditions, what about the rotor frequency is going to be less? SF, rotor frequency is going to be less, so, like, frequency is less, a slip is going to be less, R2 by S is going to be more. For example, rotor under running conditions is rotating at 4% slip. Okay, 1 by 0.04 is going to be high, so this is going to be high compared to X2, so neglect X2. Okay, so now means in solving the problem I am going to prove everything. Even if you don't understand, just keep quiet. Okay, now R2 by S if I neglect, if I consider only X2, means starting torque equal to M by omega S into V1 square divided by X2 square into R2 by 1, because starting torque, because they will have starting torque and running torque, so starting torque is going to be at starting conditions slip is going to be 1. Okay, now in running conditions, for example, TD in running conditions is going to be M by omega S into X2 can be neglected because slip is going to be less, so V1 square divided by R2 by S square into R2 by S, R2 into S. Okay, now what will happen here? If at all, if they ask you any question related to running conditions, use this equation. Okay, for example, if they ask you something related to rotor resistance is increased in speed control, we are going to increase this. Okay, so depending upon the given properties of the problem, we are going to utilize this. This equation is meant for running, this equation is meant for starting. Okay, so we are going to repeat the same multiple times such that, like, you will not remember this also. Only think of this, it's enough. In our upcoming sessions we will draw the characteristics.